I'm Jasmine Donlinger, and I manage the chemistry lab here at the Nebraska Department of Transportation. And I've managed the lab for about 14 years. And on this side of our lab, we do all our wet chemical analysis. We have our ovens where we do heat tests. We have our hoods where we protect ourselves from fumes. On these benches, we do digestions, we do filtrations, anything where we're mixing our chemicals together. This side of our laboratory is our instrument side, so all the instrumentation we use to test our materials is here. We have an X-ray fluorescence spectrometer, we have an atomic absorption spectrometer, and we have a CAM sizer, which is a computerized particle analyzer. So our job in the chemistry laboratory is to do quality assurance testing on materials that are used on our roadways. These are 4 of the more common things that we test in here. They're all seasonal. De-icers in the wintertime to keep our roads clear. We have traffic paint and glass beads that go on our pavement so that you can see the markings when you drive. And cement that goes into making our concrete roads. We test some other materials as well, soil, aggregates, but these are the more common things that I'll go into a little bit more detail for you. We test pH of the de-icers to verify they're not environmentally hazardous. We do specific gravity on our de-icers. This is to verify the consistency of the product. It's a way of measuring the density. And we use something called a pycnometer that we fill with our liquid and we put in a water bath at a certain temperature, and then we weigh it and perform the calculation. We do a total soluble solids test on our liquid de-icers, and this is to determine if there would be any distribution problems from the trucks that carry the de-icers. And we put a liter of this material into a cone here, and it's hard to see, but we have gradations on the cone, and we look to see if there's anything that's settled out. And this particular sample is very clean. There's no settleable solids. If there are settleable solids, we also pour this through a sieve to see how much is caught on the sieve, and that gives an idea on if there would be any problems in them distributing the product. Okay, we test the active ingredient in our de-icers, which is magnesium chloride, and we use the atomic absorption spectrometer to measure that. We make a solution, the instrument sucks up the solution, and there's a detector in there that gives us a concentration. We do a corrosion test on our de-icer samples to determine how corrosive the de-icer is for steel, and we use steel washers dipped in the de-icer over a 72-hour period. We do an ice melting capacity test on our de-icers. This determines how much ice the de-icer melts per milliliter. So we'll make ice cubes, we'll put it in a thermos and add our de-icer and put it on a rocker to simulate traffic and do a wait after 15 minutes. For traffic paint, we do a consistency test to determine how thick or thin the paint is, and we use a viscometer to do that. Too thin and the paint won't spread right on the roadway, and too thick, it won't come out of the traffic guns correctly. We do a dry time on the traffic paint where we put a drawdown of paint at a certain thickness, and then we have a tool that simulates a traffic tire that we use a timer, and after so many minutes we let the tool go over the drawdown of the paint and determine if it will still pick up paint or if it's dry. We also do a reflectance and contrast ratio test, and so we do a drawdown of the paint, again at a certain thickness, and we put it on a checkerboard piece of paper. So we have a tool that will measure over the white square and over the black square and take a measurement. The reflectance is how well your headlights will reflect the paint, and the contrast ratio is making sure that you can't see through the paint so that it's easy to see. We test titanium dioxide in the traffic paint. This is the active ingredient that causes reflection, and we measure out a certain amount of paint in a bottle. We add an additional chemical to it, and we shake it up. We have a wrist action shaker, and we do a drawdown, again at a really thin thickness. We use a giant hole punch to punch out a perfect circle, and we put that in our X-ray fluorescence spectrometer, and it determines our titanium dioxide content. Glass beads are used with the traffic paint. That's what is reflecting your headlights. And we have a computerized particle analyzer, which we call our cam sizer, that measures how round the beads are and also the size of the glass beads. We run a sample for 10 minutes. It measures about 2 million beads in that time. It measures the beads at 64 different angles, and it takes 60 images per second. The glass beads that we use with the traffic paint are dual coated, and one of the coatings is a moisture resistance coating. And how we test for that is we add water, and if the water sits on top of the beads, that shows that that moisture resistance coating is present. The other coating that we use on the beads is an adherence coating, and this allows the beads to adhere to the paint and not roll off the highway. We take the beads and we add a chemical called danzyl chloride, and that reacts with the coating. And that reaction causes a product that glows under UV light. So after the test completed, we put the beads under UV light, and if the beads glow, the adherence coating is present. For cement, we do a loss on ignition test, and this measures the amount of moisture and carbon dioxide that's in the cement. And we do that by measuring 1 gram of sample in a platinum crucible, and we put it in a muffle furnace at 1,000 degrees Celsius for 1 hour. For cement, we have composition requirements, and in order to test that, we take 1 gram of the cement sample, we mix it with 10 grams of this chemical, it's called flux, and we put it in another, this is a platinum and gold crucible, and we use this machine to melt it down into a mold, and it pops out as a glass disc. And that glass disc then goes into our X-ray fluorescence spectrometer that gives us the results. So I graduated from the University of Nebraska here in Lincoln with a degree in chemistry, and right out of college I began working here. My favorite part about my degree was analytical chemistry, measuring things exactly. The work that we do here, that's what we do. Quality assurance testing is we test for specification requirements. A lot of people with a chemistry degree tend to go to pharmaceutical and more biological aimed chemistry. I always liked rocks and more earth type chemistry. This job was exactly a great fit for me.